All right, so here we have answer each of these questions. We have some sort of function. Here we have the f function, and we have some given input or updated input. So it says find f of y minus 5. This is the input. If our original function, f of x, rule is x squared plus 2x. So when we're given stuff like this, we are going to be given an updated input. And what we want to do is replace the original input, in this case, x, right? So I'm going to replace my x's with y minus 5. So I got y minus 5 squared plus 2 times y minus 5. There's my first step, my substitution portion. From here, it's pretty much I need to expand, I need to distribute, I need to combine like terms, and so forth. So I'm going to show all work for this. I'm going to expand first because that's what PEMDAS tells us to do. That exponent says write that thing double time. I'm going to show my distribution with the 2. Why not? Distribute the 2 as well. I'm going to keep distributing. So we got y squared times y squared. Y times y squared. Y times negative 5, negative 5y. I'm showing a lot more work than I normally would. Distribute, negative 5 times negative 5, positive 25. I'll drop down this 2y minus 10. At this point, at this level, we tend to naturally like to write things in order, in standard form. So I'm going to go ahead and write my answer in standard form. Combine any y squares. There's no y squares. Combine all of my y's. That gives me a negative 8y. Combine my constants. That gives us a positive 15. So what this result is, I'm going to just go back. If I input y minus 5 into this function f, this is our output, right? Every single function, we input something, we get an output. If our input is a numeric input, a number, integer, whether it be integer, any number, if I input a number into a function, a number will come out. If I input something that's algebraic into a function, my output will still be algebraic. All right, let's go number 2. We have the g function. G of x is given to be 2 minus 1 half x squared. We want to find g of input n plus 2. So here's our new input. What we want to do with that new input is replace any x within the original function. In this case, only 1. So I'm going to go ahead and substitute. I'll put equals for right now. 2 minus 1 half. I'm inputting this n plus 2, and it says squared. I'm going to follow my order of operations. Order of operation tells me to do this piece first, so I'm just going to 2 minus 1 half times n plus 2. I'm going to show a lot of work here. Why not? Expanded. Still working with the same piece. I'm going to distribute. So we got 2 minus 1 half, parentheses, n times n squared. N times 2, 2n. 2 times n, 2n. And we have 2 times 2, 4. I'm going to combine like terms in that parenthesis. Let me go downward still. So we have 2 minus 1 half times n squared plus 4n plus 4. All right, so I did my exponent piece, right? That input squared. I ended up with this trinomial. Now comes my distribution of negative 1 half. So I'm distributing. Let me go here because I don't have room. So we got 2 minus 1 half times n squared, 1 half n squared, or n squared divided by 2. Negative 1 half times positive 4n is a negative 2n. Negative 1 half times positive 4, negative 2. Last thing I'm going to do is combine my any like terms that I have. these 2's cancel out. So I end up with g of n plus 2 is equivalent to negative 1/2 n squared minus 2n. This is one way of representing your answer. You can get a little fancy. G of n plus 2 is equal to negative n squared over 2 minus 2n. You can write it either or, right? It's the same thing. If you like seeing coefficients in front of your variable, then the boxed version would be how you represent it. If you don't mind meshing them together, then you can represent it like this bubble one. Either or, doesn't matter. In my answer key, you might see either or, so just know that they're the same thing, right? All right, last one. I'm going to set it up and I'm going to write my final answer. You're going to try to get there. So we have find k of a minus 3b if k of n is negative 7n squared plus n. So here's our input that we're going to be using into the original function, which has been defined as negative 7n squared plus n. Every single n is going to be replaced with this a minus 3b. So we get negative 7 times a minus 3b, parentheses, squared, plus a minus 3b. From here, I'm just going to show the expansion, and then I'm going to pause. So I'm writing this 2 times. I'm going to need to do some sort of distribution, most likely combine some like terms. And your goal is to get, I'll put it down here, negative 7a squared plus 42ab minus 63b squared plus a squared, plus a minus 3b.